Hello, and welcome back to the Maths Behind the Economics YouTube channel and the Logarithms for Economics series. This is video 17, and in this video, we are still doing practice questions. This is going to be our third and final video in which we concentrate on mathematics-based questions. In the next video, we will be moving on to working with variables and expressions that are more common in economics. And in the same way as in previous videos, I will explain you which rule I'm using, when, and why. Let's get started. Our first practice question is ln a squared to the 3 over 2 times a squared to the negative 3 times a to the 4 all over a cubed. Now, no doubt you have already heard me saying exponents and logs are intimately connected. So to tame this long and complicated looking expression, what we're going to do first is apply some of the exponent rules that we learned in the exponent series. If you don't remember those rules, then feel free to check out my exponent series, which I'm going to link you now. So first of all, we're going to bring the ln sign along for the ride, and then we're going to start applying the exponent rules. In the first term, a squared to the 3 over 2, we're raising an exponent to an exponent. So what we're going to have to do, we have to multiply the exponents together. So for now, I'm going to do some side calculations down here. So I'm going to have to multiply 2 and 3 over 2 together, but luckily, the 2 at the multiplier and the 2 at the divider will cancel each other out, so I'm just going to end up with 3 as my solution. So luckily for us, the first term is now cancelled down to a cubed. Let's see what will happen in the second term. Well, luckily in the second term we don't have fractions, so we just need to multiply together 2 and minus 3 because a squared is raised to the negative 3. So that's altogether going to be a to the negative 6. And the last term, a to the 4 doesn't change, and at the bottom I also got a cubed. Now I've got a cubed at the top and a cubed at the bottom, so the two will cancel each other out. Thank goodness, the expression is becoming simpler quite rapidly. So what we ended up here is ln a to the negative 6 times a to the 4. So now we only got a multiplication of the same bases behind the log sign, so keep the ln. And when we multiply the same base exponents together, what we do is just keep the base and then add the exponents together. Negative 6 add 4 gonna give me negative 2. Well, one last thing I can do, and I'm gonna write the final answer down in here, is bring that negative 2 exponent down in front of the expression. So it's gonna be minus 2 ln of a. Now, that is definitely much simpler than this jumbled up exponents flying all over expression that we started with. And while this looks like a logarithm question, when we actually solved it, it was more to do with the exponents than the logs. We only used one log rule in the very last step when we brought down the negative 2 exponent in the argument. All the others were applying our previous knowledge from exponents. So, as I keep saying, when you work with logs, do not forget your exponents. Let us now move on to question 2. I've got log base xy cubed times log base y squared cube root of x squared minus 5 times log base xy squared minus 2 times log base x 1 over y to the 5. Right, this is a rather long expression, so I anticipate I will need more space. Let's do that right now, and then try to think about what we can do with this expression. What we notice first is that there is a multiplication between these two logs in the first term. Furthermore, I can see that there is x in the base of the first log, which then becomes the argument of the second log with some roots and powers. And at the same time, y is in the argument of the first log with some exponents, but that's also going to be in the base of the second log with some exponents. So I think I might be able to manipulate this first multiplicative term into a form of the rule that we learned in video 14. Let us remind ourselves that specific rule, and I'm going to write that up here. So we had log some base, some exponent, and we multiply that with the log that has got x as the base and b as the argument, which then altogether cancel down to 1. So how could we potentially apply this rule here? Well, for that we would have to remove 3 from the exponent from here, 2 from the exponent from here, and the cube root and the squared from the exponents here? Well, let's start with this cube root expression. And remember, cube root of x squared is basically just x to the 2/3 because the roots are always a fractional powers. So keep that in mind and let us simplify this multiplicative term at the beginning of our log expression, where the 3 can just come down and then we end up with this relatively simple log base xy. But then what I also have to do, I have to bring down that 2/3 multiplier from the exponent of the argument, but also from video 13, when we had exponents in the base, we remember that that exponent can be brought out as a 1/2 multiplier. And now what we ended up with is just simply log yx. Now that's a lot simpler. Moving on to the other two log expressions, what we notice here that there we still have an exponent in this specific log. So I can bring that 2 multiplier down, but I've already have got a 5 multiplier, so I'm going to have 5 times 2, which is 10. And I end up with log base xy and then minus. Now here in this log expression, what I have is 1/y to the 5. And here again, I have to draw on my knowledge of exponents. 1/y to the 5 is simply just y to the -5. Remember, a 1/, exponent can be rewritten as a negative exponent. So this is y to the -5, and then when I'm bringing out that -5, I'm going to multiply that with the -2 that's already here. So altogether, that's going to give me plus 10 log xy. Okay, let's move on to the next line. And first of all, let us collect all these numbers in the first term together. So I have got a multiplier of 3, I have got a multiplier of 2/3, and I have got a multiplier of 1/2. What is that going to give me altogether? Well, this 3 will cancel out this 3, so that's going to give me a 1, and then this 2 cancels out that 2, and that's going to give me a big 1 again. So at the end, I just end up with log base xy times log base yx minus 10 log xy plus 10 log xy. But hold on, I'm taking away something and I'm adding that very same thing to the expression. Well, then that's basically gonna cancel down to 0. And this multiplication at the start is just 1. Remember, we multiply log expressions where the argument and the base switches from the first term to the second term. That's always going to cancel down to 1. So this long, jumbled up, complicated looking log expression is nothing else but 1. Wow, 1 was hiding rather well in this log expression. Now, after all that feast of calculations, let us move on to the question number 3 and, as always, make some more space. Well, this question is going to be a 1/2 times log base 345 plus log base 3 square root of 20 minus log base 330 plus log base 3 6 minus log base 3 2. Now, first of all, we notice that all the log bases are 3. So thankfully, we do not have to change any of the bases. Next, what we spot is that there are additions and subtractions between these log signs, but there is a 1/2 multiplier in the first term. So we need to remove that before we can bring these log expressions on the one log sign. So the first that I need to do is log base 345 to the 1/2, which I'm going to remember that it's always a square root. But for now, I'm just going to copy the rest of the expression. Next, I'm going to keep log base 3, and then I'm going to think about what to do with the arguments. When there is addition, that's going to be a multiplication, but because we have got two subtractions, that means we're also going to have a fraction. So first I'm going to write down the fraction line, and now what's going to be at the top? At the top, there's going to be the ones that have got additions between them. So at the top, I'm going to have these two plus this argument. So altogether, that's going to be 45 to the 1/2, which is square root of 45, times square root of 20. And then the whole thing is still multiplied by 6. So now I add that with this term, and this term. I still have to deal with this term and this term. but those terms have got a subtraction in front of them, so those terms are going to have to go down into the denominator. So that's going to be 30 times 2. Next, I am still keeping the log base 3, but now I've got root 45 times root 20, so that's going to be one root sign. But quite frankly, I don't want to calculate 45 times 20. I remember that 45 is 9 times 5. What's furthermore is that 9 is 3 squared. And then what I also remembered that 20 is 4 times 5. What's furthermore that 4 is 2 squared. So altogether under the root, I have got the multiple of these two numbers, which is 2 squared from here, times 3 squared from here, times 5, which is going to give me the 5 squared. So those two are also gone now. There is another 6 at the top, and at the bottom I've got 30 times 2, and 30 is just 5 times 6. So keep the log sign. Now, under the root, everything is raised to the second power, so basically that root will cancel out every one of those second powers. So after removing the root, I'm going to end up with 2 times 3 times 5 times 6. At the bottom, I'm going to have 5 times 6 times 2. And I kept the 6 because there's a 6 at the top and there's a 6 at the bottom, so I can cancel that out. There's a 5 at the top and there's a 5 at the bottom. I can cancel that out. There's a 2 at the top and there's a 2 at the bottom. I can cancel that out. So all of these cancel down to 1. So the final answer is going to be log base 3, 3. And again, 1 is hiding here. 1 likes to hide quite a bit, doesn't it? Well, this was another rather long calculations when we used quite a few different tricks. And I strongly suggest that whenever you see big numbers, just try to break them down into multiplications of smaller numbers where you will be able to work them with somewhat easier. Okay, so space again. And now question number 4. ln x times bracket open 1 plus y to the z. Well, you could argue that this is already relatively simple, but let's see if we can apply some log rules and manipulate this into a slightly different form. First of all, what I noticed is that there is a x and a bracket of multiplication. So I can apply the multiplication behind the log rule, and I can break this out into ln of x plus ln of 1 plus y to the z. Why was that good for me? Well, it was good for me because now I can bring down that z from the exponent and I can make it down into the front. So that's going to be ln x plus z times ln 1 plus y. Well, I can't do anything else because there is an addition behind the log sign and there is no rule for that. So this is my final form. But let us just stop here for a moment. Why on earth would anybody want to do this? Well, in the first expression, behind the log sign, I have got this multiplication, and what's more important, this is raised to a power. So basically, behind the ln sign, I have got an exponential expression. But now, after I apply the log rules, behind the log sign, I've only simply got some kind of linear expression. So you will come across this method in your economics career, most likely when you study econometrics, as log linearization. So the whole point of applying a log to an exponential expression is that now, with that tool of log, I can manipulate the whole expression into a linear expression. And linear expressions are much simpler to deal with than exponentials. So, in your studies, please keep an eye out for this log linearization. Last question for the video. Square root of e to the 4 plus ln 4. Well, if you kept up with my videos, you probably know what I'm aiming for here. Well, I want to apply the rule of b to log base bx being equal to x, which we covered in video 6. Now, for our case, this should look like e to the ln something being equal to that something. Whatever is in the argument, that's going to come down as the simplified version of the expression. However, there are a few things in my way before I can get to that expression. formally I have got a root, and moreover, in the exponent I have got a sum, not just a simple ln. So let us deal with those step by step. First thing first, we remember that a root is a fractional power. So I'm going to keep e to the 4 plus ln 4, and now I rewrite the root as a half power. And now, again, remembering my exponent rules from the exponent series, when I raise an exponent to an exponent, I just need to multiply those exponents together. So I'm going to keep e half times 4 plus ln of 4. Write the rest of the expression here. E stays, so I'm going to multiply everything inside the bracket with the half. So I've got half times 4 plus a half times ln 4. Well, a half times 4 is just 2, plus a half can be brought up into the exponent, so that's going to be ln 4 to the half. Now, I want to rewrite 2 as an ln because I want to have just e to the ln something to be able to apply the rule up here. So how can I do that? Well, 2 is going to be equal ln e squared. We really deeply need to understand the basic concept of the exponents to be recognized when we can rewrite a number as a log. So if you feel like this is still beyond you, go back and check the first couple of videos in the series. So now I can rewrite this as ln e squared plus ln. What is 4 to the half? Well, the half power is the root, so square root of 4 is just 2, so that's just going to be ln of 2. Okay, now again, carry on down here. I'm going to keep e. In the exponent now, I have got an addition of 2 logs with the same basis because both of them are ln. I made sure that both of them are ln. So I can apply the multiplication behind the log rule in reverse, and I can rewrite this as ln e squared times 2, or simply 2e squared. Now I have got e to the ln of something, so I can cancel down this whole expression to the argument of that ln, and that is just 2e squared. Much, much simpler than that square root of e to the something. Okay, so this was video 17. This was the third video when we looked at simply mathematical expressions of logs. In the next video, we're going to move on to working with these logarithmic expressions, but using variables and formulae which are more common in economics. I hope to see you there. Bye!